So here is the problem. Verify that for all real values of m, Clairaut's equation y is equal to x y prime plus f of y prime has y is equal to mx plus f of m as a general solution. Also show that the parametric equations x is equal to negative f prime of t and y is equal to negative t f of prime of t plus f of t define another solution which is in general singular relative to the preceding general solution. And we have a hint that states show that the given parametric expression for x and y satisfy an equation of the form ax plus by plus c is equal to 0 if and only if f of t is linear. So this is how you solve the problem. Y is equal to x y prime plus f of y prime. First, we will let m be equal to y prime. Thus, y is equal to mx plus f of m. There you have the general solution, and then we can get the parametric equation of this. First, derive the whole equation, then we will get dy over dx is equal to, here we will use the product rule. So derivative of x times m plus dm over dx times x plus dm over dx, this is dm over dx times the f prime of m. Since here m is equal to y prime and we all know that y prime is equal to dy over dx, thus we can say this is also m, and since dm over dx, we can also substitute it as t. So this is m is equal to x, no, the derivative of x is 1, so this will be m plus dm over dx will be xt plus t f prime of m. So since we will subtract the whole equation with m, we will get, this is cancelled, so it will be already xt plus t f prime of m is equal to 0. So in order for you to get the parametric equations, we will extract the t. So t times x plus f prime of m is equal to 0. So t is equal to 0 and x plus f prime of m will be equal to 0. So here, in order for you to get the x, we will transpose f prime of m to the other side. So the answer will be x is equal to negative f prime of m. So we will substitute it to our original equation here. So we will substitute x. So y is equal to the value of x, which is negative f prime of m, or we can say this is f prime of t, times y prime, or y prime is equal to, we can also have that as t, plus the f of t. We only use the t variable in order for you to have the same variable in the on the ones that is needed in the problem. So the answer will be already is equal to y is equal to negative t f prime of t plus f prime of t, or if you want to rearrange it, it will be already equal to f of t minus t f prime of t. So this is the one you are getting.
Any differential equation of the form y is equal to x g of y prime plus f of y prime is called Lagrange equation. One can differentiate with respect to x. Hence, we have y prime is equal to g of y prime plus x times g prime of y prime y double prime plus f prime of y prime y double prime. So with this equation, we can rewrite this as dx over dy prime is equal to the quantity of g prime of y prime all over y prime minus g of y prime times x plus f prime of y prime all over y prime minus g of y prime. Clearly, this is a first-order linear non-homogeneous differential equation which can be solved using the formula y of x is equal to e raised to the negative integral of g of x dx times the quantity of the integral of e raised to the integral of g of x dx times f of x dx plus c. So we have an example on page 63, number 92 on Advanced Engineering by Wylie, that about the light rays emanating from the origin that are refracted, and you have to find the equation of the curve. So upon derivation, you have y is equal to 2xy prime plus y times y prime squared. So as you can see, this is a Lagrange equation. So we must identify first the g prime, the gx and the fx. So the gx is here, so g of x is equal to 2y prime, and the f of x is equal to y prime squared. So with this formula, you use this formula and just substitute. So dx over dy prime is equal to the derivative of gx, which is only 2 over the y prime minus 2y prime times x plus the derivative of the f of x, so it will be 2y prime all over y prime minus 2y prime. Then upon simplification, we will get dx over dy prime is equal to 2x all over negative y prime plus negative 2. So here we have already the dx over dy prime, so we will have this as our new gt and ft. So our gt will be already negative 2 times y prime raised to the negative 1, and your ft will be negative 2. So substitute it in this formula. So y of x is equal to e raised to the negative integral of the gt, which is negative 2y prime raised to negative 1 dx, then times the quantity of the integral e raised to the integral of the gt, which is negative 2y prime raised to negative 1 dx, then the ft, which is negative 2 dx plus c. So simplifying it further, we will get, so this is cancel, so the integral of this will be the e 2 ln of y prime times, here you can factor out the negative 2, so negative 2, then integral of the answer of this is e to the negative 2 ln of y prime dx plus c. So in this theorem, you can transform 2 ln y prime into 2 ln y prime squared. So since this is e raised to the ln, the ln will be brought down. So y of x is just equal to y prime raised to 2 times negative 2, here just the same, integral of ln y prime raised to 2 dx plus c. So continuing, we have the y prime of 2 times negative 2 integral of ln of y prime squared dx plus c. And when you integrate this is just y prime squared times negative 2, then the x, since this you can only factor it out since this is x, so x ln of y prime squared plus c. So x will be equal to y prime raised to negative 2 times 2/3 y prime cube plus c. So just distribute it, so you will get x is equal to 2/3 y prime plus c times y prime raised to the negative 2. So this is the equation of the curve that we are looking for. So that's it.